Okay, this is the video for 5.6 more or less, and this is a practice understanding task. Today we're going to be solving systems of inequalities, and the solution to a system of inequalities would be a feasible region in the plane, meaning any point in the feasible region is a feasible solution or a possible solution to the system of inequalities. So let's begin with number one. The system is the two standard inequalities. Negative 5x plus 3y is less than or equal to 45. And then 2x plus 3y is greater than 24. So your first step would be, let's plot boundary lines. All right. And now, when I have an inequality in standard form, to plot the boundary line, I'm just going to use intercepts. So I do a little table, and at the y-intercept, x is 0. So let's look at this first inequality. If x is 0, negative 5 times 0 is gone, leaving me 3 times y is 45. Or y is 45 divided by 3, 15. That's my y-intercept. And now at my x-intercept, y is 0. So let the y be 0, so the 3 times 0 is gone, and you're left with negative 5 times x is 45. Well, 45 divided by negative 5 would be a negative 9, so the x-intercept is negative 9. So let's plot our intercepts. 0, 15, negative 9, 0. And now the boundary line, is it solid or dash? Do you see the equal sign right there, less than or equal to? So our boundary line needs to be solid, meaning any point on that boundary line is a possible feasible solution, depending on our other inequality. All right, so let's go ahead and do the intercepts of 2x plus 3y is greater than 24. So again, at the y-intercept, x is 0, so if I let x equal 0, 2 times 0 is gone, and I'm left with 3 times y is 24. 3 times what number is 24? Well, that would be an 8. And if the y is 0, the 3 times 0 is gone, and we're left with 2 times what number is 24? And that would be a 12. So the x-intercept is the ordered pair 0, 8. And the y-intercept is the ordered pair 12, 0. Now this boundary line, there's greater than. There's no equals here, so therefore the boundary line is going to be dashed, meaning a solution, a feasible solution, cannot exist on this boundary line. Now, shading. We've got to do the double shaded region. And let me introduce something, although we're going to do a little more on the early problems, all right? But again, some of you can already tell what the double shaded region would have to be because you look at your y terms in the inequality, okay? Shading, feasible region. Do you notice that in the top inequality we have 3 times y, so our last step would be to divide by 3 if we were solving for the y. And then we're going to get y is less than or equal to, and if you're dividing by 3, that inequality will not reverse. So I know I'm going to have to be less than or equal to the boundary line for negative 5x plus 3y is less than or equal to 45. So something below or on the bold boundary line. Now the other one, 2x plus 3y greater than 24. Well, again, I have 3 y's, so my last step to solve for y would be divide by 3, which will not affect the inequality because we're dividing both sides by a positive number. So the greater than will stay greater than, meaning I have to be above the dash boundary line. So if I am below the solid boundary line and above the dash boundary line, my feasible region is going to be this geometric figure right there. All right, but let's take this a little farther. Let's take both of these inequalities and put them into slope-intercept form because then we can check a lot of things. So slope-intercept form, I need to solve for the y. So do you see the negative 5x let's get rid of that first. Add 5x to both sides, which will not affect your inequality symbol, less than or equal to. And then you have your 3y is left, but the negative 5x and the 5x will cancel each other out. So we just have on the left 3 times y is less than or equal to, and these are not like terms, so I cannot combine them. So I'm going to write the x term first. I have 5x's plus 45 more. And there you go. And now one more step. That was mentioned earlier. We're going to divide everything by 3 to undo this multiplication by 3 right here. So let's just divide every term by 3. And we're dividing both sides by a positive number. Does not reverse the inequality symbol. So we are still less than or equal to. And on the left, my 3's cancel, leaving my factor of y. So y is less than or equal to. And now if we simplify these two terms, we're going to see everything we need to see. All right? 5/3 does not simplify. 5/3 and my factor of x, I like to write out front. You could leave it written like that if you want, but this clearly shows a slope of 5/3. Plus, and 3 goes into 45 15 times. All right, so let's just visualize our solid boundary line and make sure we have a y-intercept of 15 and a slope of 5/3. Well, here's my solid boundary line, and the y-intercept is 15. And now let's choose another point clearly on that line. How about right there? Now, am I going to, well, let's go right down here. That looks like a good point. Am I going to rise 5? 1, 2, 3, 4, 5, and then run 3. 1, 2, 3. So the slope of 5/3 works and the y-intercept of 15 works. So that's perfect. Now this also confirms y is less than or equal to 5/3 x plus 15, meaning I'm shading below it or I can be on it. Okay? Now, let's go to our 2x plus 3y is greater than 24. Subtract the 2x's from both sides, which will not affect our inequality. And 2x minus 2x is gone, leaving 3y is greater than, and again, let's put our x term first, negative 2x plus 24. By the way, you do not have to do it. All right, you could have written that 24 minus 2x. But now let's divide every term by 3 again to solve for the y. And dividing both sides by 3 will not affect your inequality symbol, greater than still. And on the left, your 3's cancel, leaving your factor of y. And now let's simplify. A negative over a positive is negative, and the fraction 2/3 does not simplify, and then your factor of x. So the slope is negative 2/3. Plus the y-intercept, well, how many times does 3 go into 24? That would be 8 times. So I get y is greater than negative 2/3 x plus 8. Greater than means I shade above the dash line. And let's see if we have a y-intercept of 8 and a slope of negative 2/3. Well, here's the y-intercept of 8. And if I drop 2 and run 3, 1, 2, 1, 2, 3, I'm back on that dash line. Everything checks out. So I know that y is less than or equal to, I am below the solid boundary line. Y is greater than, I am above the dash boundary line. And so my feasible region is this region up here. Shade the whole thing, all right? And any point in the feasible region, including on the solid boundary line, but not, by the way, on that dash boundary line, is a feasible solution. So that's our solution to number 1. So number 2, let's do the same thing. Negative 10x plus 6y is less than or equal to 90. Wow, that almost looks familiar. Look at the first inequality for number 1. Negative 5x plus 3y is less than or equal to 45. Do these two inequalities look like we simply took the first inequality And did we just multiply everything by 2? If that's the case, we didn't change anything. So let's just check this real quick. 2 times negative 5x is negative 10x. Check. 2 times 3y would be 6y. Check. And 2 times 45 is 90. So guess what? The first inequality in each system would be the same inequality, and we already have that boundary line. So let's go graph the boundary line for the first inequality from number 1. And there it is right there. And again, we would shade below that. We remember that too. So now all we need to do is find the boundary line for 6x plus 9y is greater than 36. Now that's close to 2x plus 3y is greater than 24. But if I multiply this by 3, I get 6x's plus 9y is greater than, and 3 times 24 would be 72, not 36. So this one, we're going to have to find our boundary line with intercepts. And in this table, the y-intercept, x is 0. So 6 times 0 is gone, and we're left with 9 times y is 36. Well, 9 times what number is 36? That'd be a 4. All right? And at y equals 0, we have our x-intercept, so the 9 times 0 is gone, and you are left with 6 times x is 36. So 6 times what number is 36? That would be a 6. So let's plot our y-intercept. The ordered pair is 0, 4. And then the x-intercept is the ordered pair 6, 0. And now the inequality is greater than, there's no equals, so the boundary line has to be dashed. That goes through those 2 points. All right. Now, I see the 9y's, so I'm betting we're going to shade above. But let's prove that. Let's take 6x plus 9y is greater than 36 and put that inequality in standard form. Let's put it into slope-intercept form. Yeah, that's my bet. Let's see if it works out. All right, so to solve for y, I'm going to have to subtract 6x from both sides. Does not affect my inequality. So 6x minus 6x is gone, leaving the 9y is greater than. And again, these are not like terms, so I'm going to write the x term first, negative 6x plus 36. And now let's divide both sides, or every term, by 9, which 9 is a positive number, does not affect my inequality. And on the left, my factors of 9 cancel, leaving my factor of y. Y is greater than, a negative over a positive is negative. And 6 over 9 would reduce to what? 2/3. And then don't forget your factor of x. Plus 9 goes into 36 4 times. So let's double check everything. We should have a y-intercept of 4 on our dash line. Well, the dash boundary line, the y-intercept is 4, and now we need a slope of negative 2/3. So let's just go from our y-intercept and drop 2 and run 1, 2, 3. Are we back on that dash boundary line? We are, therefore everything checks, including our conjecture y is greater than negative 2/3 x plus 4. So we are shading above. So we are below the solid boundary line. We are above the dash boundary line. That would give us a feasible region of this region right there. Now, any point in this feasible region, including this solid boundary line right there, will work. But if I am on this dash boundary line, that point would not work. Okay, number 3. Is the point negative 3, 10 a solution to the system in problem number 1? Why or why not? Well, here's the system from number 1, and let's get our solution on this slide. There it is, beautiful. Now let's just plot negative 3, 10, that ordered pair, and determine if it is in the feasible region, the shaded region on this plane. So x is negative 3, 1, 2, 3, y is 10, there's 5, there's 10, and we're at the intersection of the 2 boundary lines right there. So my point can be on the solid boundary line but not this negative boundary line right there. Therefore, negative 310 is not a solution to this system. The answer is no. And again, why? The boundary line for one of the equations is dashed. Therefore, the ordered pair cannot be on that boundary line at all. All right, number 4. Oh, look at this. They have the solution to a system of inequalities here, which would be this feasible region in blue, including parts of each boundary line because those are solid. All right, so let's write the system. You're going to like this. All you do is take this one boundary line at a time. And since each boundary line has y-intercept and I can probably see the slope, I'm going to do each of these inequalities in slope-intercept. I'm going to use my old y equals mx plus b. So let's start with this boundary line right there. Y in terms of x. And now think about the inequality. We are on the boundary line because that's solid and above it. So on or above, wouldn't that be greater than or equal to? And now I need a slope. So let's find a couple points that are clearly on this boundary line right here. How about our y-intercept of 2 right there? And then where's my next perfect point? Way over right there. All right, what's my rise? It looks like I'm going to rise 1 and run 1, 2, 3, 4, 5, 6. So y is greater than or equal to 1/6 x, and now all I need is the y-intercept, which we said was 2 plus 2. There's my first inequality. Now let's go ahead and find the inequality representing this boundary line and everything below it. So y in terms of x. And again, we are on the boundary line right here or below it. So that would be less than or equal to, and now we need a slope. All right, so we could probably use our y-intercept. Let's see if I did. Yes, and now I need another perfect point. Looks like right there. Yes. So what's my rise? -1, -2, -3, -4, -5. So let me put the negative out front and the 5 in my numerator. And then what's my run? Let me get there again. -1, 2, 3, 4, -5, and then I'm running 1, 2. So my slope is -5 over 2 times x, m times x, plus b. And the y-intercept of that boundary line was 10. All right, we have one more and we're done. All right, this boundary line and the shaded region, y in terms of x. So now I am on or below this boundary line. So wouldn't that be less than or equal to? And now we need a slope again. So we have that same y-intercept. Let's find another key point right here. Hey, it looks like, would this point work right there? That looks pretty good. Yes. So what's the slope from this point to that y-intercept? Well, I'm going to rise 1, 2, 3, and I'm running 1, 2. Rise over run, 3 over 2. So y is less than or equal to 3 over 2x plus my y-intercept, which that's also a 10. Now, I have my 3 inequalities here that makes up a system of inequalities to create a solution that is this feasible region right here. All right. Now, we like to write our system together, so I like to use a birdie bracket. All right, and then let's just list each inequality one at a time within the birdie bracket to create our system of inequalities. So let's start with, and it doesn't matter, order doesn't matter, but y greater than or equal to 1/6x plus 2. Y less than or equal to -5/2 x plus 10. And y less than or equal to 3/2 x plus 10. And there's our system right there. That's nice. Okay, now Amanda is looking at Frank's system right here, all right, and she disagrees. Amanda is examining Frank's work on number 4 when she exclaims, "You have written all of your inequalities backwards." So she's concerned about, the greater than or equal to being less than or equal to, and so on. All right. The solution set to your system would look like this. What do you think about Amanda's statement? So Frank said the feasible region was on and inside this triangle right here. And Amanda's saying, no, we have 3 different feasible regions. So an easy thing to do would be this. Let's bring out Frank's system. There it is. Nice job, Frank. And let's find a point that's going to be simple to use in Frank's feasible region. I would use one of the points right on the y-axis, so x is 0. Maybe this 0, 4 right there. See that point? Well, the coordinates of that point, your x is 0 and your y is 4. Now, if we substitute this point into each inequality in Frank's system, we should get a true statement for every one of Frank's inequalities, assuming that this is the feasible region. So, reason we like to do this, see, my y's will all be 4, so let's change every y here to a 4. And then, this is why I used the y-intercept too, by the way. The x's are all 0. That means I will lose every term that has a factor of x. There they all go. And now, do I have true statements? Is 4 greater than or equal to positive 2? Yes, it is. Is 4 less than or equal to positive 10? Yes, it is. And is 4 less than or equal to positive 10 again? Well, we already said that. Yeah, it is. So everything checked out. So this point, 0, 4, is a feasible solution. Therefore, Frank was correct. The feasible region would be everything on or inside this triangle right there. Come on, Amanda. Frank's system of inequalities looks very correct, and we have just proven that. Number 6, Carlos and Clarita. Hey, we haven't heard from them in a while, and what are they doing in this activity? Anyway, I guess they wanted to get into systems of inequalities, so welcome, Carlos and Clarita. Carlos and Clarita have found a cat food that seems to appeal to even the most finicky of cats. That cat food is called Figaro Flakes. They want to mix it with a less expensive cat food, Tabitha Tidbits, to make an affordable but tasty cat food. So, do you see this paragraph right here? When we're translating a paragraph into a system of inequalities, that's a little more complicated than the translations we have done previously. All right? Might be a little bit concerned, but you can handle it. The first thing I would do is declare my variables. So let's read the question. Write and solve a system of inequalities that Carlos can use to determine possible combinations of Tabitha Tidbits and Figaro Flakes that will satisfy both of these constraints. Wow. All right, so let's declare our variables. Tabitha Tidbits contains 4 grams of protein and 6 grams of fat per scoop. So I think my variable will represent the number of scoops of Tabitha Tidbits that I'm going to use and the number of scoops of Figaro Flakes that we're going to use in our recipe. So let's say X equals the number of scoops of, and my first food would be Tabitha Tidbits, TT. And then Y will be my number of scoops of, and my other food is Figaro Flakes, the fancy, more expensive stuff. All right, so there we go. We've declared our variables. Now let's read and start translating. So Tabitha Tidbits contains 4 grams of protein and 6 grams of fat per scoop. Figaro Flakes contains 12 grams of protein and 4 grams of fat per scoop. Carlos wants to make a meal for cats that contains at least 8 grams of protein and no more than 6 grams of fat per scoop. So we need a protein constraint and a fat constraint. So 4 grams of protein. Here's our protein constraint right here. All right. And Tabitha Tidbits, we're using X for. So if Tabitha Tidbits contains 4 grams of protein, I'm going to call that 4 times the number of scoops of Tabitha Tidbits, or 4X. And 6 grams of fat, but we're not talking fat yet down here algebraically, per scoop. Figaro Flakes contains 12 grams of protein. We need that one. And we're using Y for the number of scoops of Figaro Flakes. So that's going to be plus 12Y. The more expensive food has a lot of grams of protein. All right. Now, what's our constraint? And 4 grams of fat, not yet. But Carlos wants to make a meal for cats that contains at least, so that would be less than or greater than or equal to at least what? 8 grams of protein. So there's our protein constraint right there. 4x plus 12y is greater than or equal to 8. Now, we're talking 6 grams of fat. So we need our fat constraint. And I think you're going to notice that the cheaper cat food is going to have more fat than the inexpensive cat food. Let's find out though. Okay, that's just a conjecture. So, Tabitha Tidbits has 6 grams of fat. That would be a 6x. Figaro Flakes contains 12 grams of protein and 4 grams of fat per scoop. So that'd be plus 4y. And our conjecture was correct, right? Okay. This more expensive, cat food has less fat. All right, now let's finish our constraint. Carlos wants to make a meal for cats that contains at least 8 grams of protein. We dealt with that. And no more than, so that would be less than or equal to. Less than or equal to what? 6 grams of fat. 6. And there's our fat constraint. We have written our system right there. Now we need to solve it, which means we're going to need to graph these 2 inequalities on the same plane and find a feasible region. So we've got this, and here's our plane right here. Okay, now these are inequalities in standard form, so we will use intercepts to do the boundary lines. So at the y-intercept, x is 0, and at the x-intercept, y is 0. And in our protein constraint, if x is 0, we're left with 12y is 8. So that would mean y would be 8 over 12, which we could reduce to 2/3. And now, if y is 0, 12 times 0 is gone, and we're left with 4x is 8. 4 times what number is 8? That would be a 2. So let's plot our y-intercept of 2/3. We're going to have to approximate this and look at the hash marks. Is that 0.2, 0.4, 0.6, 0.81? Yes. So 2/3 would be 0.2, 0.4, 0.6. It'd be between 0.6 and 0.8, and that's about 0.6 repeating. That'd be about right there. Look at that. And then 2, 0 for the x-intercept. That's a little easier right there. Now look at your inequality for your boundary line. Is it solid or dashed? I see an equal sign. It's solid. And by the way, I think we're going to shade above that one, but we'll get there in a second. Okay, let's do our boundary line for 6x plus 4y is less than or equal to 6. So our intercepts when x equals 0, 6 times 0 is gone, and I have 4y is 6. So y would be 6 over 4, which again, let's reduce that to 3 over 2. Okay, and now when y is 0, this is gone, and 6 times what number is 6? Well, that'd have to be a 1. So let's plot our y-intercept of 3 over 2. Oh, I'm going to have to approximate that. 1, 1.2, 1.4, 1.6. So 1.5 would be about right there. Look at that. And then 1, 0 for the next, right there. And again, we have an equal sign, so the boundary line is solid. And let's think about, we're not going to put both of these into y-intercept form to double check because we're confident right here. What we're going to do is, do you think you are ready for Mr. G's method of shading? Again, I just look at the y term. That's 12 times y. 12 is a positive number, so when I divide by 12, my inequality will not change. So I have to be greater than or equal to the blue line, and 4 times y, I'd have to divide by 4 on the last step, and that implies this inequality will not change. So I have to be less than or equal to the red line. So greater than the blue line, less than the red line, that would be this triangular region right there. There's my feasible region. Isn't that cool? All right, so that is the perfect solution to this system of inequalities. So, have we answered the question completely? I believe we have. Number 7, based on your work, suggest at least 3 different recipes using each type of cat food that meets Carlos's nutritional goals. For example, would 1 scoop of Tabitha Tidbits and 1/2 scoop of Figaro Flakes be an acceptable meal? Well, let's find out with our solution. There's our solution. Notice how I took out a little bit of my shading so I could see the grids better. Now, let's check 1 scoop of Tabitha Tidbits. And I think we were measuring Tabitha Tidbits on the x-axis and Figaro Flakes on the y-axis. So 1 scoop of Tabitha Tidbits, well, that'd be right there, 1. All right, but I also need then a 1/2 scoop of Figaro Flakes. So I am plotting the point 1, 1/2. So 0.2, 0.4, 0.6, that point would be about right there. And that point is not in our feasible region, so that is not a possible solution. It's not going to work. But we need to find at least 3 different recipes that will work. All right, so let's find some simple points in our feasible region. And they can be within this triangle or because of our boundary lines on the boundary lines. So let's see. We'll do a little table. Number of scoops of Tabitha Tidbits. All right, well, let's find some points here. That looks good. That looks good. And how about right there? Would you all agree that those 3 points are all within the feasible region? So Tabitha Tidbits would be the equivalent of our x-coordinate of each of those points, which I see a 0. And then those are 0.2, right? 0.2. And then 0.4. And now my corresponding Figaro Flakes coordinates, or the equivalent of y coordinates, which I see a 1. Another 1, and then this one, 0.8. Now, those 3 points, or those 3 ordered pairs, are different recipes. For instance, I could do 0 scoops of Tabitha Tidbits and go all Figaro Flakes in just 1 scoop, and we're good. So let's read the problem and make sure we've answered it appropriately. Based on your work, suggest at least 3 different recipes using each type of cat food. Oh, this I'm not using any Tabitha Tidbits. So I'm going to break out my red pen. Look, I get to break out the red pen without even asking you guys for a question. I'm not going to use that point. So I'm going to have to find another point where I'm using some Tabitha Tidbits, because we have to have Tabitha Tidbits and Figaro Flakes as part of our recipe. That's what they said right there. Where'd my pen go? Using each type of cat food. All right, so, well, let's find another point. How about, let's see, where'd my red pen go? hard to see. There it is. Well, this point right there, would that work? It's hard to do a point with my red pen on the PowerPoint, but I'm doing my best. There it is right there. And now that X would be 0.2. All right. And we used 0.2 earlier, but that's okay. We can do that again. 0.2. Don't pick on me. This is hard to write on this PowerPoint like that. All right. And what's the Y coordinate? Well, let's just go 0.2, 0.4, 0.6, 0.8, 0.8. Great, I had to pick an 8 that I need to write with this pen. All right, let's do my best. Oh, look at that. Not bad. All right, now there's 3 recipes using both Tabitha Tidbits and Figaro Flakes, and I think we're very good. So let me highlight those 3 recipes. Where'd my pen go? There it is. So all 3 of these recipes would be appropriate because all 3 of those points are in the feasible region, and in all 3 of those recipes we are using both Tabitha Tidbits and Figaro Flakes. Now you guys complete your Ready Set Go for 5.6 and get a hold of me if you need some extra help. All right, I'm always available, and have some fun. This is cool stuff. Everybody have a wonderful day.